this is 3.7, graphing absolute value functions, part 2. So first we're going to look at vertex form, and this is where it is written, we have some function, which is some function, equals a times the absolute value of x minus h plus k. And a cannot be 0, because that would make this whole part 0, and then you'd end up with a horizontal line. So, if a is not 0, we have the vertex form here. It's called vertex form because it gives us our vertex, h and k. If it's a minus h, this vertex is positive. If you have a plus h is negative here. And it is symmetric about the line x equals h. That is a vertical line. And symmetric means you can think of it like the mirror line. So if I were to graph f of x equals the absolute value of x plus 3 minus 2, I know that this is in vertex form. My a is a 1. There's an invisible 1 in front. This k means it will shift down 2, and this plus 3 is going to move it to the left 3 units. I could make a table of values, plugging in some x's here and getting out different f of x, and then I could graph it, or I could think I would shift to the left 3, down 2, and my slope is 1, so I go up 1 to the right 1. And I have my line, or my absolute value function. It's not exactly one line. If I were to graph g of x equals 2x plus the absolute value of 2x plus 3 minus 2, this is going to be a horizontal shrink. The 2 moves it down 2, and plus 3 moves it to the left 3. So to see what my points are, I can make a table. And if I plug in negative 2, x equals negative 2, I have 2 times negative 2 plus 3, which is the absolute value of negative 4 plus 3, which is the absolute value of negative 1, which is 1 minus 2 is negative 1. Doing the same for all of these x values, I would have my center would be at negative 1.5. I know that it's going to be in between 1 and 2 because 1 and 2 have the same y values. If they have the same y values, that means that the reflection has happened somewhere in between here. So I chose 1.5 to see what happens. So you would have your vertex at negative 1.5, negative 2, and your slope is going to be up 1, and then you can plot your points here. You could factor out this 2, and so if I have the absolute value of 2x plus 3 minus 2, if I factor out a 2, it's undoing the distributive property. So I'd have 2 times the absolute value of 1.5, x plus 1.5 minus 2, because 2 times 1.5 is 3. And this 2 would be my slope, and the vertex is negative 1.5, negative 2. If this does not make sense, you can always make a table. The table is the tried and true way. Now just to understand a little bit more of what vertex form means, I have g of x equals a times the absolute value of x minus h plus k. A little difficult to see, but it's there. So I have a, and each part in here does something different. So this k is a vertical shift. If it's a plus k, it moves up. If it's minus k, it moves down. H here is a horizontal shift. If it's minus h, it moves to the right. If it's plus h, it moves to the left. A is a vertical stretch. If A is larger than 1, it is a stretch. If A is less than 1, still greater than 0, it is a shrink. A negative in front means that it's going to flip over the x-axis. So it will flip over the x-axis like a calendar. Calendars go up and down. Or if I have a negative in front of x, it is going to reflect over the y-axis like a book. So let's look at this. All I'm going to do is describe the transformations that are happening in this function. So I start with my parent function, f of x equals the absolute value of x. G of x equals negative 3 times the absolute value of x minus 2 plus 4. I know this 4 is going to shift it up 4. 2 is going to be a horizontal shift to the right 2. The 3 is a vertical stretch by 3, and the negative reflects over the x-axis. So my original, before the reflection, means I'm going to have my vertex at 2, 4. To the right 2, up 4. I get that from h and k. Then my slope is 3, so I go up 3 to the right 1 to get my next point. Up 3 to the left 1. But then this reflected over the x-axis means that it is going to be down here. So this is the point to negative 4, because I take what was up here and flip it over the x-axis, and it gets pointed down because it is mirrored, it is reflected.